This is SpaceTime Series 20, Episode 57. Coming up on SpaceTime, the smallest star ever seen, why black holes only seem to come in two sizes, and strange signals from outer space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have identified what could be the smallest star ever discovered. The star, called EBLM J0555-57Ab, was detected in the triple star system located some 600 light-years away in the Southern Hemisphere constellation Pictor the Painter. A report in the journal Astronomy and Astrophysics claims the tiny star's diameter is smaller than that of Jupiter, the largest planet in our solar system, and only slightly larger than Saturn. In spite of its small size, this star is still extremely dense, some 85 times more massive than Jupiter. That means the star does have enough mass to undergo core protium-hydrogen fusion into helium, the process which makes stars like the Sun shine. Any less massive and it would have been a brown dwarf, substellar objects around 13 times the mass of Jupiter, which fill the gap between the smallest stars and the largest planets. EBLM J0555-57Ab is a spectral type M red dwarf star. Although they're the most numerous stars in the universe, with sizes and masses less than 20% that of the Sun, they're still poorly understood, since they're difficult to detect due to their small size and low brightness. The star was identified through a planet hunting experiment called WASP as it transited or passed in front of the system's much larger primary star, a method usually used to detect planets, not stars. As it passed in front of the primary star, as seen by WASP, it formed an eclipsing stellar binary system. The parent star became dimmer in a periodic fashion with the signature of the orbiting object. Thanks to this special configuration, scientists can accurately measure the mass and size of any orbiting companions, in this case a small star. The star's mass was established by spectroscopic Doppler observations of wobbles in the primary star's position as the smaller companion star orbited around it. The study's lead author, Alexander Boettcher from the University of Cambridge, says the discovery reveals just how small stars can get. Any smaller and the pressure at the centre of the star would no longer be sufficient to enable hydrogen fusion to take place. As it is, once the star burns off enough fuel, it may well go below that mass requirement, becoming a brown dwarf. These very small dim stars are also some of the best possible candidates for detecting Earth-sized planets which can have liquid water on their surfaces, such as TRAPPIST-1, the ultra-cool red dwarf surrounded by 7 temperate Earth-sized worlds. The newly measured star has a mass comparable with the current estimate for TRAPPIST-1, but a radius that's some 30% smaller. Boettcher says the star's not just small, it's also likely colder than many of the gas giant exoplanets so far identified. While a fascinating feature of stellar physics, it's often harder to measure the size of such dim low-mass stars compared to many of the larger exoplanets that we're finding. But finding them is important because the smaller stars provide optimal conditions for the discovery of Earth-like planets and for the remote exploration of their atmospheres. However, before scientists can study exoplanets, they first need to absolutely understand their host stars. You're listening to SpaceTime. I'm Stuart Gary. Citizen scientists have helped NASA identify a never-before-seen brown dwarf. The discovery is the first made as part of NASA's Backyard World's Planet 9 Citizen Science Project. News of the brown dwarf, known as WISE-A J110125.95 plus 540052.8, has been published in the Astrophysical Journal Letters. Astrophysicist Mark Kuchner from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says astronomers realized they could do a much better job of identifying Planet 9 if they opened the search up to the general public. And although Planet 9 is still eluding the planet hunters' efforts for now, the project has been turning up a lot of interesting brown dwarf discoveries, with some 118 candidates so far identified. It's been roughly 2 decades since researchers first discovered brown dwarfs, and the scientific community has eagerly opened its eyes to this new class of substellar objects between the smallest stars and the largest planets. For years, Kuchner has been fascinated by infrared images of the entire sky, captured by NASA's Wide Field Infrared Survey Explorer, or WISE spacecraft, which was launched in 2009. The space telescope's designed to observe cold objects emitting most of their light at long wavelengths, objects like brown dwarfs. With its initial mission complete in 2011, WISE was deactivated. It was then reactivated 2 years later in 2013 as NEO-WISE, a new mission funded by the NEO Observations Program with a different goal, searching for potentially hazardous near-Earth objects, or NEOs. Previously, Kuchner had focused on stationary objects seen by WISE, but the Backyard World's Planet 9 project shows the WISE and NEO-WISE data in a way custom-tailored for finding fast-moving objects. Kuchner and his team layer many images of the same location in the sky to create a single, comprehensive snapshot. These images are then combined with several similar co-edited pictures, forming a sort of electronic flipbook showing motions over time. Any member of the public with internet access can scour these flipbooks and click on anomalies. And anything moving relatively quickly stands out. Kuchner and colleagues then follow up the observations using ground-based telescopes to glean more information. WISE J110125.95 plus 540052.8 is an interesting and exciting discovery because it's unusually faint, meaning the project's team of citizen scientists are probing much deeper than anyone had before. See, the thing is, while computers can efficiently sift through deluges of data, they also get lost in all the details that human eyes and brains easily discard as irrelevant. That's why lots of websites include special check numbers for you to repeat to make sure you're not a robot. The problem is, mining all this information can be extremely arduous for a single scientist or even for a small group of postdocs. And that's why collaborating with an enthusiastic public is so effective. Many eyes catch details that one pair alone could easily miss. While Kuchner is delighted with this early discovery, one of his ultimate goals for the Backyard World's Planet 9 project is to find the smallest and coolest types of brown dwarfs known, spectral type Y brown dwarfs. Some of these Y dwarfs could be looking closer to us than Proxima Centauri, the nearest star to the Sun. Their low temperatures make Y dwarfs extremely dim, so faint that it takes quite a bit of work to pull them from the images. And that's where Backyard World's Planet 9 comes in. Kuchner anticipates the project will continue for several more years, allowing heaps more volunteers to contribute. I'm Stuart Gary. You're listening to SpaceTime. A new study may have finally answered a question which has been puzzling astronomers and physicists for half a century. Namely, why black holes only seem to come in two general size groups: stellar mass black holes and supermassive black holes. Stellar mass black holes are created through the collapse of very massive stars far larger than the Sun at the end of their lives. They usually have masses around a few tens of times that of our Sun. At the other end of the scale are supermassive black holes, usually found at the centres of galaxies. The origin of these is still somewhat hazy, but we do know they have masses millions to billions of times that of the Sun. And while merging stellar mass black holes have been shown to produce objects 30, 40, maybe even 60 times the mass of our Sun, there's still a huge gap between that and supermassive black holes well over 1 million solar masses larger. So that begs the question, what's happened to all the intermediate-sized black holes? Those with just a few thousand times the mass of our Sun. Now, a report in the journal Nature Astronomy has come up with one possible answer: time. Professor Tal Alexander from Israel's Weizmann Institute and Ben Baror from Princeton University, New Jersey, have hypothesized that there may be few intermediate mass black holes in the universe today because of the way they grow. You see, black holes grow by consuming stars, gas, and anything else that gets too close, including other black holes. The authors calculate that black holes grow at an average rate of about 1 solar mass every 10,000 years. And if you include dark matter into that mix, they'd grow even faster. But of course there's no evidence that black holes consume dark matter. Anyway, what it all means is that a stellar mass black hole, which formed out of the death of a massive star very early in the universe, say 13.5 billion years ago, would most likely have reached an intermediate mass stage about 1.6 to 2.2 billion years after the Big Bang. And if it kept feeding at the same rate, it would have reached the supermassive black hole stage not long after that. However, what happens if the black hole came into existence a lot later on, at a time which means they would have grown into an intermediate-sized black hole by now? Well, the authors claim black holes of this size may only reside in dense globular star clusters, making them hard to find. Now, this is all hypothetical, and there are still heaps of buts and what-ifs which need to be considered. To find out more, Andrew Dunkley speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
Let's look at black holes. They only come in small and extra large, and we haven't known why. Have they figured it out yet?
Apparently they have, yeah. This is, I think, quite an important piece of research that's come from collaboration between scientists in Israel and in the United States. Do you know what a black hole is, Andrew? It's
a singularity.
Oh, that's very good. That's very, very good.
Yeah, but okay, I don't know what that is.
Well, you and I are singularly good at explaining these things. Mm-hmm. So actually the definition of a black hole is it's a point at which the density of space is infinite.
Right.
So, and look, that immediately blows your head in.
Yes.
We know water has a density of 1 gram per cc, but something with infinite density, we really can't get our heads around it. But that is the definition of a black hole, and we know that they exist. First, the phrase was coined, I think, in 1967 by John Wheeler. I think I'm right in saying that. Anyway, a point where the density of space is infinite. What that does, because we know from Einstein's general theory of relativity that any sort of matter in space curves the space around it. That's actually the effect we feel as gravity when we sit here on the Earth, usually held onto our seats when we're sitting down by gravity. That's not, as Newton thought it was, it's not a force pulling us down. It's the fact that the space around the Earth is slightly distorted. So the shape of space at your feet is slightly different from the shape of space at your head, and you feel that as a force pulling you down. So black holes, of course, having this infinite density in a very, very small space, they distort the space around them enormously. They curve the space violently around them. And what that does is, first of all, prevents any light escaping from a black hole, which is why they're called black holes. Mm-hmm. They have so much gravity that even light can't escape. But it also means that when you look at a black hole, and hopefully very soon we'll be doing that with big radio telescopes, you'll see the distortion of the space around it in a very kind of weird and wonderful way. It looks like a lens in space because of the way it distorts it. Now, that's black holes 101.
Okay. I'm still confused, but that's all right. It's just me.
No, I'm confused as well. How can we see black holes in space? Well, it's by their effect on their environment. That's basically what allows astronomers to see them, because they do tend to collect stuff. Black holes usually have a disk of material around them. It's called the accretion disk. Accretion is just a process of collection, basically, a fancy word for collecting stuff. The accretion disk is where gas and dust and probably occasionally stars, they get into this maelstrom of circulation around the black hole before they're gobbled up by it. They basically whiz around at significant fractions of the speed of light and are gobbled up by the black hole. It's the sort of jostling of material within this accretion disk that actually allows us to see the black hole, because that jostling emits X-rays and radio waves and a few other things. So even though the black hole is black, the accretion disk is glowing.
And you make it sound so elegant, Fred, but it's actually cataclysmically violent.
It is. Seen from the outside, it's not bad. But yes, if you were in that accretion disk, well, you'd be getting spaghettified. That's what happens. You fall into a black hole, you turn into a string of spaghetti. So to cut to the chase here, we know about black holes. We can observe them. We can see their effect on the environment, and that allows us to weigh them, to measure their mass. For example, the black hole that is at the center of our galaxy, the Milky Way galaxy, has a center in the constellation of Sagittarius. We know there is a black hole there because we can see its effect on stars that surround it. And in fact, those stars circulating around it, actually quite close to the black hole, but in no danger from being dragged in by it because they're far enough away. The movement of those stars allows you to weigh the black hole. That essentially qualifies it to be called a supermassive black hole. Now, we believe there is a supermassive black hole at the center of every galaxy. In fact, some galaxies have supermassive black holes whose mass is measured in billions, not millions, of solar masses, not tons. There's far too many tons to talk about. It's solar masses that we measure these things in the mass of the sun. So some black holes at the centers of galaxies are billions of times more massive than the sun. Are you still with me, Andrew?
I am, Fred, yes. I actually understand, mega-sized things in terms of what's happening in space. It's hard to imagine, but I do understand they exist.
We are born megalomaniacs in the world of astronomy. Right. Now, the other extreme is that we also see black holes that have about the same mass as the sun, maybe 2 or 3 or 10 or perhaps even 50 times the mass of the sun. We believe they are formed when really massive stars explode at the end of their lives. And so that's a process that's relatively well understood. We know how these things came into being. But the two big questions are, one, why do we never see anything with a mass of, say, 10,000 times the mass of the sun? There's nothing in between.
A not so super middle-sized black hole.
Exactly, that's right. That's the professional term that's used for this. Not so super middle-sized black hole. We don't see them.
No.
There aren't any. We see the solar mass-sized ones, and we see the billions or millions of solar mass-sized ones, but nothing in between. And the other question is, how did those big ones get so big? And the answer has now come from these scientists I mentioned at the beginning, based in Israel and the United States. And what they've shown is that probably the black holes at the centers of galaxies may well have formed in the very early phase of the universe, perhaps 10 to 12 billion years ago. The universe is about 13.8 billion years old. We know galaxies were forming prolifically early in that period, so maybe 10 to 12 billion years ago. And what these researchers have demonstrated is that black holes do gobble up stars with a fair degree of rapidity. And in fact, they've put a number on it. They reckon that a black hole will collect one solar mass of material in the form of stars, in other words, 1 times the mass of the sun, about every 10,000 years. So they suggest that it's a constant rate. So these black holes are growing 1 solar mass every 10,000 years. That sounds very slow.
So if you do the maths and add it up over 13.5 billion years, you get supermassive black holes.
You got the bottom line there in words far more concise than I could ever put together, which is why you're a radio star and I'm just an astronomer.
I wouldn't say just an astronomer versus a radio presenter. It's, the universe is apart.
Indeed, and that's a pun and a half there. But so that's the point, that if you grow a black hole slowly over long enough, you get the supermassive ones at the end. And if all black holes do that, well, it means you never see these intermediate mass ones.
Yeah, if we'd been around 7 to 10 billion years ago, we would have seen middle-sized ones.
Yeah,
gotcha.
That's right.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program Space Nuts. And this is Space Time. I'm Stuart Gary. If you want more Space Time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. Astronomers at the Arecibo radio telescope in Puerto Rico have detected strange signals which appear to be originating from a nearby star system. The mysterious signals appear to be coming from Ross 128, a small red dwarf star about 11 light-years away. No planets have yet been detected around Ross 128, which is some 2,800 times dimmer than the Sun. Scientists detected the unusually almost periodic radio signals over a period of 10 minutes. SETI, the Search for Extraterrestrial Intelligence, has been notified of the detection. However, no one, other than maybe the History Channel, are claiming they're aliens just yet. Scientists say the signal's far more likely to be a passing satellite or some ground-based interference rather than a sign of the Big A. Mind you, Arecibo and aliens do go together. The giant 305-metre dish is well known for its role in the movie Contact, and it is undertaking a real-life scientific effort to search for signals of extraterrestrial intelligence as part of the SETI project. And while an orbiting telecommunications satellite remains the most likely cause, astronomers at Arecibo admit they've never seen satellites emit bursts like that, describing them as very peculiar. So, apart from aliens, what else could they be? Well, as Ross 128's a red dwarf, another possible explanation for the strange signals could be a stellar flare, an outburst of energy from the star's surface. Our own star, the Sun, emits solar flares as well. These geomagnetic storms, often referred to as solar storms or space weather, commonly erupt from the Sun over an 11-year solar cycle. When they blast towards the Earth, they can affect and even destroy satellites, affect telecommunications, and also terrestrial power grids. But they do give us some spectacular-looking northern and southern auroral activity as well. Solar flares, or in this case stellar flares, would be far more common on red dwarf stars than on stars like the Sun. That's because of their simplified internal structure. Unlike Sun-like stars, which have a radiative zone around the stellar core surrounded by a convective zone further out, red dwarfs are thought to only contain a convective zone. The team are now trying to take another look at the same region of the sky to see if the same signal returns. If it doesn't, then a satellite or terrestrial source will be far more likely than ET. Right now, the best candidate for a signal from ET remains the famous Big Wow, a strong narrowband radio signal detected by Ohio State University's Big Ear telescope on August the 15th, 1977. It's called the Big Wow because that's what the astronomer on duty at the time wrote when he saw the signal appearing in his data. The Big Wow signal has an alphanumeric sequence of 6EQU J5, which represents the intensity variation of the radio signal over time. More interestingly, two different values for the signal's frequency have been given, 1420.36 MHz and 1420.46 MHz. That's significant because both are very close to the 1420.41 MHz frequency naturally emitted by hydrogen. This so-called hydrogen line has long been speculated to be the most likely frequency that any extraterrestrial civilization would use if they were attempting to communicate using radio signals. That's simply because hydrogen's the most common element in the universe, and any intelligent sources sending signals our way would probably already know that. However, the Big Wow signal has never been repeated, and it's now thought that it could simply be interstellar scintillation of a weaker continuous signal. Other hypotheses include a rotating lighthouse-like source such as a pulsar, a signal sweeping in frequency, a one-time burst, an Earth source signal that was simply reflected off a piece of space junk, or possibly a hydrogen cloud surrounding two comets, 260CP Christensen and 335P Gibbs, both of which were roughly in the right position at the right time. The mystery continues. And this is SpaceTime. I'm Stuart Gary. The SpaceX Falcon 9 rocket has successfully launched the heaviest payload ever carried by the company into geostationary orbit. The 6,070-kilogram Inmarsat 5F4 telecommunications satellite is at the very top end of the Falcon 9's lift capabilities. Initially, SpaceX were planning to launch it using their new heavy lift vehicle, the Falcon Heavy, which combines 3 Falcon 9 core stages mounted side by side. However, the Hawthorne, California-based company is yet to bring the new launch vehicle to flight status, something now slated for the end of the year. Those delays have already led Inmarsat to moving its EuropaSat spacecraft to an Arianespace Ariane 5 ECA. However, by using the Falcon 9 V1.2 or full thrust version in its lighter expendable configuration without landing legs or grid fins, and by not reserving fuel for a core stage return to Earth maneuver for recovery and reuse, mission managers were able to launch the Inmarsat 5F4 into a geostationary transfer orbit. The Falcon 9 full thrust configuration uses a colder and hence denser liquid oxygen, allowing high-performance Merlin 1D engines to replace the previous Merlin 1Cs and a stretched upper stage which holds additional propellant. Both the core and upper stage still use RP-1 rocket-grade kerosene propellant combined with a liquid oxygen oxidizer. The mission blasted off from the former Space Shuttle and Saturn V Apollo Moon Rocket Launch Complex 39A at the Kennedy Space Center at Cape Canaveral in Florida.
AFTS is go for launch.
PC verify F9 is in startup.
Falcon 9's in startup. All ground side gas closeouts are complete. Stage 1, Stage 2, press for flight.
LD's go for launch.
Falcon 9's configured for flight.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2.
Vehicles programming to
Just over T plus 1 minute into flight, we're hearing nominal callouts. The Merlin engines have throttled down in preparation for passing through the period of maximum dynamic pressure.
Vehicle experiencing maximum aerodynamic pressure.
A minute and a half into flight, we're through the period of maximum dynamic pressure. The Merlin engines are throttled back up to full power. Trajectory, performance continue to look nominal.
MVAC engine chill has begun.
You hear the call out, MVAC chill has begun. Liquid oxygen now on top of the turbo pump for the second stage engine, chilling it in as we prepare for stage separation and then ignition of the upper stage engine. Next major event coming up in less than 30 seconds is going to be main engine cutoff, shutdown of the 9 Merlin engines, followed by stage separation and ignition of the second stage engine.
The Falcon 9's 9 Merlin 1D core engines burnt for 165 seconds before MECO or main engine cutoff and stage separation. The Falcon 9's upper stage then ignited its single vacuum optimised Merlin 1D engine for the first of 2 burns.
Stage check confirmed.
T plus 3 minutes and 15 seconds into flight, a good stage separation, ignition of the upper stage engine.
The payload fairing was jettisoned 40 seconds into the upper stage's initial 5-minute 46-second burn.
Next event coming up, fairing separation.
Fairing check confirmed.
T plus 3 minutes, 50 seconds into flight. A good fairing separation. We heard confirmation over the countdown net. Second stage engine continues burning. This will go until about T plus 8 minutes and 38 seconds, at which time we would have shutdown in a parking orbit around the Earth.
An 18-minute 21-second coasting phase followed the completion of the initial upper stage burn, followed by a final 55-second engine burn to bring the satellite into its final geostationary transfer orbit.
Second stage engine is on the first of 2 planned burns. As I said, the first one will put us in a parking orbit, followed by a second burn about 27 minutes into flight that would put Inmarsat into a geostationary transfer orbit, followed shortly afterwards by spacecraft separation. Performance continues to look nominal on the upper stage. Chamber pressures look good, engine looks good, trajectory looks good.
Built by Boeing on a BSS 702 HP satellite bus, the Inmarsat 5F4 is the last of 4 high-speed broadband satellites developed for the company's internet service. It's equipped with 89 Ka-band transponders and carries enough fuel for a 15-year lifespan. At this stage, the new satellite will act purely as a backup in case one of the company's other 3 satellites fail. I'm Stuart Gary. You're listening to SpaceTime. A 1 trillion tonne iceberg, one of the largest ever recorded, has carved away from the Larsen C ice shelf in Antarctica. The 5,800 square kilometre chunk of ice, now named A68, is twice the size of the Australian Capital Territory, as large as the US state of Delaware, and contains twice the volume of Lake Erie, one of the Great Lakes. Scientists have been monitoring an ever-expanding rift in the ice sheet for several years. In 2014, a crack that had been slowly growing into the ice shelf for decades suddenly started to spread northwards. As the split continued to advance, several unsuccessful attempts were made to move a British Antarctic research station on the ocean side of the crack onto safer ground. The carving occurred sometime between July 10 and July 12. The final breakthrough was first detected by data from NASA's Aqua Motus satellite instrument, which images in the thermal infrared at a 1 kilometre resolution. As the iceberg was already floating before it carved away, it won't have any immediate impact on sea levels. The carving of this iceberg leaves the Larsen C ice shelf reduced in area by more than 12%, and the landscape of the Antarctic Peninsula changed forever. The continuing development and expansion of the rift over the past year has been monitored using data from the European Space Agency's Sentinel-1 satellites. Sentinel-1 is a radar imaging system capable of acquiring images regardless of cloud cover and throughout the current winter period of polar darkness. Although the remaining ice shelf will continue to regrow, scientists have shown that the new configuration is potentially less stable than what it was prior to the rift. The Larsen C ice shelf, which has an average thickness of between 200 and 600 metres, floats on the ocean at the very edge of the Antarctic Peninsula, holding back the flow of glaciers feeding into it. Researchers had been monitoring the rift in Larsen C for many years, following the collapse of the Larsen A ice shelf in 1995 and then the sudden breakup of the Larsen B shelf in 2002. Glaciologist Dr. Martin O'Leary from Swansea University says while the carving event's a natural process, it places the ice shelf in a very vulnerable position because it's the furthest back the ice front's been in recorded history. Scientists are closely monitoring the situation for any signs that the rest of the ice shelf is becoming unstable. If the ice shelf loses much more of its area, it could result in glaciers that flow off the land behind the shelf speeding up in their passage towards the ocean. And it's this non-floating ice which would have an impact on sea levels. Though this specific event's not directly linked to human-induced climate change, the simple fact is the Antarctic Peninsula, has become one of the fastest warming places on the planet, and global warming from human activity is to blame. The latest scientific data shows average global temperatures have risen by 1.07 degrees Celsius, with March's average global temperature smashing a 100-year-old record. On top of that, it also increased by the greatest margin ever seen for any month. Climate change is usually assessed over years and decades, but even hardened climate scientists have been shocked by recent unprecedented increases in temperatures. Japan's meteorological agency claims while February was already well above the long-term global average, driven largely by climate change, it was however shocked to find out that March was even hotter. Data released by NASA also confirmed that it was the hottest March on record, and temperatures globally are continuing to climb. The trend's important because 2015 temperatures demolished the record set in 2014 for the hottest year ever seen. And that was based on records stretching back to 1850. The UK Met Office now expects 2016 to be even hotter, meaning global temperature records are now set to have been broken 3 years in a row. Global warming's already driven profound environmental changes, including the total collapse of the Larsen A and B ice shelves. And temperatures have risen dramatically in this region over recent decades. That's meant summer temperatures are now frequently above freezing, and the associated surface melting significantly weakens the ice shelves. The major warming of the subantarctic ocean is strongly impacting on the thick ice shelves from beneath. Scientists are now trying to determine if the warmer ocean waters caused by climate change could have triggered the collapse of Larsen C by eating away along anchor points at the base of the ice shelf. Iran Seger from Australian Skeptics says the carving of Larsen C is deeply troubling.
It is part of a trend of warming in Antarctica in particular. This is not the only ice shelf. In fact, it's not even the biggest ice shelf that has broken off. And the problem with those breaking ice shelves is not just what they do themselves. The main problem is that they expose the ice sheet behind them to erosion from the sea. And that is obviously a major problem long term.
What scientists are mostly concerned about is an accelerated rate of glacial movement as a result of this.
Absolutely. Although it's important to remember that the main problem from a melting perspective in terms of rising sea levels is not the ice in Antarctica, but rather the ice in Greenland. That is the ice that people are really worried about, that scientists are really worried about. Once that melts, if that melts completely, then we're talking about sea rises of potentially 7, 8, 10 meters.
Is that simply because there's less ice sheeting in Greenland as opposed to the huge expanses of ice shelves around Antarctica, which are already floating on water so they won't affect sea level?
So my understanding is that the ice in Greenland is more of it is outside the water, whereas in Antarctica, a lot of the ice is already in water. It will have less an effect. Yeah, the displacement's already there.
One of the big concerns in all of this is the ongoing attacks by climate change skeptics who simply will not look at the scientific evidence. Rather than look at the facts, they'll cherry pick what they want, and it doesn't really tell the full picture. And that's got to be concerning.
Absolutely, although I must say that my first concern is to correct you that they're not skeptics.
They're climate change deniers.
Absolutely, they're climate change deniers, and it's important. It's a good opportunity for me to say that skeptics, or scientific skeptics as we call ourselves sometimes, look at the evidence and follow it wherever it may lead. We do not base our decisions on what we want to be true, but rather on what the evidence shows is true. And when the evidence changes, we change our minds. That is the core principle of what being a skeptic is. And climate change deniers definitely are not skeptics, because no matter how much evidence there is, they do not change their minds. And it's important to point specifically to a study that was done by Naomi Oreskes, who's a professor of science history, and Eric Conway. They wrote this book, Merchants of Doubt, where they actually showed that it's not just the same techniques, but actually the same people and organizations that are pushing the anti-climate change message are the ones who, years ago, pushed the tobacco cancer message. Yeah.
So what can we infer from that, the fact that these same people are doing both? What does that tell us?
The important thing is, as the name of the book infers, Merchants of Doubt, when they were doing that with tobacco, what they were saying was that their product is doubt. They were not trying to say that it's not happening. All they wanted to do was sow doubt. And that is exactly what they do today. And the way it shows itself is in the technique of simply saying all kinds of things that sometimes contradict each other. However, they create doubt in the population's minds about whether climate change really is as serious, whether it's really happening, whether we should do something about it, whether it's cost effective to do something about it, all kinds of different arguments that do not necessarily gel together. However, each one by itself, people feel like it's not really something that we need to do anything about.
And some of the arguments are reasonable. I mean, if Australia were to engage in all its Paris climate agreements, it wouldn't change the rate of global warming one iota.
I wouldn't say it wouldn't change it one iota, but it would have obviously a very small effect because we emit only a small proportion of all the carbon dioxide that humans emit into the atmosphere. However, if every country said the same thing, then obviously nothing would happen. So the whole point is that all countries of the world, small and the large, the big emitters and the small emitters, all need to collaborate in order to prevent a future catastrophe.
But can you see the concerns that Australians would have when they find out that what we do here has very little effect, and yet countries like India and China, they'll be allowed to continue polluting it at the same, if not accelerated rates for decades to come?
To say that China and India are allowed to continue to pollute, they have severe restrictions set on them as well, except they're not the same restrictions that are put on the West, where the emission of climate-changing gases is already very high as it is.
They can see how Australians would take that to mean that. How do you educate them away from that, especially when they look at energy bills, which are going to be as high as what? We've just announced a 20% increase in electricity charges, simply because it's an electricity cartel.
Again, I'm glad you mentioned that, because that is another, basically, as we say in Australia, it's a furphy. It's got nothing to do with climate change. It's got nothing to do with renewable energy. It's got nothing to do with investment in clean energy. It's got everything to do with mismanagement of the local power market. It's just propaganda to say that it does. The coal industry is being subsidized twice, or the fossil fuel industry. And the reason they're subsidized twice is, first of all, once they're subsidized directly. There's government subsidies for these industries in order to build and maintain their facilities. But there's also another subsidy, which is a societal subsidy, and that is the fact that they do not pay for the harm they cause the environment. In most other industries, you pollute, you have to clean up the pollution behind you. However, that's not what happens with fossil fuels.
There are a lot of arguments being put up by climate change deniers to justify their stance. And the big one, of course, is that it's not a man-made problem, it's part of a natural cycle.
What is different now is the rate of change. Usually this kind of change, a rise of 1 to 2 degrees in the average global temperature, is something that would take 20,000 years to happen. And here we're talking about something that happens over 150 years. It's just unprecedented, and the effect on the environment and on humans is immense.
The next one would have to be the sun's getting warmer anyway. It is true. The sun is slowly heating over time, but we're talking about geologic time for that.
We're talking about geological timescales. We're not talking about something that changes over 150 years. The kind of changes that the sun undergoes that affect climate more readily or more noticeably is just differences in activity. You know, the sun has an activity cycle, and we see that when the sun is more active, there is indeed a bit of more warmth put into the atmosphere. However, over the past few decades, what we're seeing is that the global temperature trends and solar activity have no correlation at all, and very often they actually go in opposite directions.
Another great mantra is that humans don't cause global warming. Volcanoes do. Every time a volcano erupts, there's huge piles of CO2 that get pumped into the atmosphere.
It is true that when volcanoes erupt, they emit CO2 into the atmosphere, but they also emit sulfur, which actually acts to counter some of the CO2. More importantly, that's part of the natural cycle. That happens anyway. What humans do is on top of the natural cycle, and that is why we're seeing this huge increase in global temperatures over the past 200 years or so. So it's important to note when we're talking about the natural cycle and the human effect that climate scientists look into all of these things. This is all part of the calculation. It's not like climate scientists don't know that there is this natural cycle. It's not like they don't know that volcanoes erupt. They take care of all of these things in their calculations. And despite that, several studies since 2004 have shown that around 97% of climate scientists accept that human emissions of greenhouse gases, especially CO2, are the primary reason for the global warming we're seeing today. That's what's called a scientific consensus.
But that brings us to our next point. One of the favourite sayings of the climate change deniers is that, well, not all scientists agree that climate change is real. There are lots of scientists who disagree with that.
The reason we say scientific consensus is important is because of what it means. It means that the experts, the people who specialize in this area of science, in this case climate, have come to the conclusion that the evidence is incontrovertible. They've come to the conclusion that all the evidence suggests, in this case, does CO2 cause global warming, CO2 specifically emitted by humans? All the evidence shows that it is, and while there can be a discussion around mechanism and feedback loops and what we can do about it, it's all within the framework that it is caused by human emission of carbon dioxide.
How does one respond to these cherry-picked arguments? Is there a generic answer one can give other than simply saying the science doesn't care if you believe it or not?
Science fiction author Philip K. Dick said that reality is that which, when you stop believing in it, doesn't go away. The fact that people do not believe climate change is real does not make it go away. It's reality. It's an unfortunate reality. we're not talking about something that happens tomorrow morning. We're talking about something that is progressive, that will take, worst case scenario, we're talking about 60, 70 years before we see some of the worst effects start to happen. Most of the people who are alive today will not be alive when the worst of these things happen.
It's a sentence you're giving your grandkids.
It's a sentence you're giving your grandkids. You're basically causing harm now that will only be experienced by the generations to come.
Of course, that's a message we have to get into the heads of the politicians. They spend a lot of egotistical hours thinking about the sort of legacy they're going to leave behind. Well, unless they do something about climate change and start doing that now, the legacy is one which won't look favourably upon them.
The biggest reason to act now is because we are reaching some tipping points, places where we may not be able to reverse or to even stop the worsening of climate change. Because, for example, if the permafrost in Siberia thaws,
you've got the methane release then, yes.
Methane will be released into the atmosphere. Methane is a much more potent greenhouse gas than CO2, and we will not be able to stop that.
That's Eran Segev, president of Australian Skeptics. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts, or Audio Boom. This has been another quality podcast production from Bytes.com.